Thank you very much, Helena, and hi to everyone on the call. My name is Dakkak, and I work at Ericsson AB. I'm the head of customer support systems in service area network. And today I will be presenting our continuous deployment journey that we have taken at Ericsson throughout the past few years, and also talk a little bit about what comes next from our end. In today's presentation, we will start by looking first at continuous deployment and the two words of continuous deployment: embedded systems versus cloud and online applications. Then we will dive into the radio access network continuous deployment as being practiced at Ericsson. We will talk then about the role of data and support. And we will touch a little bit by the end of this presentation about what comes next and what are our challenges in continuous deployment at Ericsson.
Anas, excuse me a little bit. There is a message in the chat saying that the sound is a little bit difficult, a little bit blurry. Is there any way in which you can improve sound from your end?
Yes, probably I can put my other headphones. Let me try to see if that's better.
Sorry, we try, and if not, then we...
Let me try with cabled ones. Let's see. Is this okay?
At least we do our best to have everyone here as good as possible. So let's try this, Anas.
Right. Is it better now, Helena?
I think it is, and I hope also the person who sent the message think it is. So let's go on. Right. Yes, thumbs up.
Okay, thank you. So we were saying that there are two words existing for continuous deployment: the word of online and cloud applications, where the big software companies such as Google, Netflix, and Facebook are deploying to production many times a day, up to thousands, with very short lead time for deployment and high reliability. Versus we have the online applications, or embedded applications, sorry. And in Facebook, for example, whereas they can deploy thousands of times to production, or at least once a day to production in the online application, they deploy once a week to twice a week to the Android and iOS application. The same thing happens in the automotive industry, and this is from a recent research. The paper is included here that shows deployment to field cars happen annually or semi-annually for most of the survey participants that were part of this they were part of this survey, mostly coming from German manufacturers, whereas there are very few manufacturers that can deploy monthly or less than or semi-annually. In the radio telecommunication networks and in telecommunication in general, we used to have a twice a year deployment cycle, release and deployment cycle. And these two words, as you can see here, are quite different, with huge gap in between, from thousands to less than to once or twice yearly or semi-yearly. And of course, since most of us come from embedded system companies, there are many reasons that can make this type of release and deployment quite logical. High reliability and availability is, of course, one of them. In addition to that, these embedded systems are often mass markets. So there are many instances of them in different markets operated by people or customers in the case of the telecommunication system, for instance. Therefore, the software development organization is not the one taking decisions all the time about deploying and pushing a new software to the customer. But in addition to that, there's also another aspect, which is the impact a fault or a problem could have on the company or on the customer. And this is, for example, from a few years back, where a problem in Ericsson software has caused major implications for different operators across the world. And it was also highlighted in different news outlets. The same thing happens with we can see it in other mobile operators in different parts of the world. Software problems can be extremely expensive from technical perspective and also from commercial perspective, impacting the operator's image. And hence, in our case, in the telecommunication systems, operators often do extensive testing and validation for any new software that comes from the vendors. And they often also see that new software, they often have a trust issue with the new software. They need to make sure that it works before deploying it into production or into their network. Now, having that in mind and looking at what Ericsson's over the years have done in the area of continuous deployment and how they, to large extent, try to change this long release and deployment cycle to more often ones. And before diving into the details, I want just here to give a highlight of what we mean by a radio base station in the context of radio access network. So a base station is often contains two parts, the antenna and the radio parts depicted here in the picture to the right. And then the digital part, which is contained into a cabinet and has baseband units and the transmission units as well, in addition to some other environmental and high availability aspect like extra batteries as depicted here in this case. At Ericsson, the current practice is to release and deploy software every 2 to 4 weeks, depending on the technology. So 2 weeks for the later technologies such as 5G and 4G, and 4 weeks for the older technology such as 3G. The deployment is not to all customers and all instances of the radio base stations globally, but targets specifically here CD zones and CD customers, or continuous deployment zone and continuous deployment customers, as I will talk about in shortly hereafter. And within the CD zones and with CD customers, new features and contents are being validated and tested within these two timelines here, 2 weeks and 4 weeks frequency. Before continuous deployment, the software development project, there are two aspects of running a software development project. First, the development itself, which used to take 6 months. So from the beginning here, we decide what type of features and implementations we need to do. And then the development starts by the developers coding, pushing their code to main track, and building, of course, system images that contains the codes and verify them and test them internally. At the same time, with the start of the development project, we start a field acceptance and validation project that first of all look at trying to identify which customers we want to validate the new implementations with, and what are the requirements these customers should have in terms of configurations, in terms of availability, in terms of also way of working. And the preparation parts take considerable amount of time, almost 3 to 4 months from the 6-month release cycle. And by the end of the development project, when almost all features are ready and validated internally, we start pushing some software drops to what we call FOA customers in order for these softwares to be validated within these customers' network on a small scale. And as you see here, this is a pure waterfall development project where everything has to be decided in the beginning in terms of the implementation scope, implemented, and by the end of the project validated with very selected customers in order to make sure that the work is done, the software is working as expected. And often we run into many problems here at the very end of the project that doesn't work as we wanted. There are problems that we didn't anticipate, and the performance is not according to what has been projected. And then it's a hot fixes all the time in order to manage the software's quality and make it available for what we call general availability, so the software can be released for all customers and used by them. So from this model of development and deployment, at least validation, to another model where the software deliveries are broken into fixed intervals. said 2 to 4 weeks. And also the GA availability has been shrinking from 6 months to 3 months. And whenever there's a development done, by Wednesday every second week, for example, in the LTE release, a software image will be pushed to customers and made available for them to download and deploy in their networks, depicting here a continuous delivery aspects of the continuous of the software building practice, so to say. And then the customers take this image and validate it into a lab in a very short cycle, and then deploy it into a CD zone, which I will talk about in a moment. So the main differences between the previous model and this model is that software drops are happening throughout the development cycle. Even though we still decide which content needs to be part of this GA, the boundaries between GAs is not as fixed as before, as you see here in this dotted line. So if something is missed or not ready in the previous GA, it's fine to take it in the next GA, because the time between GAs have been also reduced to 3 months from 6 months. But the most important thing is that the software drops will not happen by the end of the development only. They will happen throughout the development in continuous approach, delivery to customers and then deployed to customers. At the same time, instead of relying on only few customers to validate the software, number of customers who take the continuous releases have been extended to many customers for two reasons. One, to give these customers the advantage of time to market, but also to give us at Ericsson the confidence that the software works in different configurations and different contexts. Now, looking a little bit on zooming into a high-level view of the continuous integration, delivery, and deployment process. Continuous integration is here depicted by two main lines, and there are actually more than two main lines here. One highlighting the system software, where it used to build the final deployable image of the system, and one highlighting a platform or component of the system, where it continuously tests and validates new commits that come onto that track, and then at certain moment of time or continuously push towards the system software track, and the new image is built. Now, there are different tests that are done within each track. So the component track tests on component level, and then the system track tests on system level. Every 2 or 4 weeks, as mentioned, we then create another release branch where we run some out delivery testing, which are aiming at validating the software with higher traffic loads and more aggressive testing scope to make sure that it can stand before it's deployed to the customer, before it's released to customers. In addition to that, to validating the software from quality perspective or non-functional perspective, we also run legal testing scope, such as making sure that emergency calls are getting prioritized when the cells or the nodes are congested, which are a very important aspect of the telecommunication networks that needs to be validated and work in all times. So in order to also make sure that nothing is missed, so the legal aspects are covered and also non-functional aspects are covered, a small or a short release branch is created, and the validation, before deployment validation test cases are running there. Now, after the release, and here the CD release depicted by the purple circle, there are some activities which are done with the customers. So first of all, customers will look at the documents that have been produced with every release. They read them, iterate themselves, or reflect on the content of these releases. Then they start running a lab testing and validation in their own context, which is often the case. And we have had a lot of discussion with the lead customers in order to shorten the validation and tests with the customers in their labs. But most importantly also is that before the deployment, there is a freeze period to make sure that we have a stable baseline in order to compare the performance of the software post-deployment. And we use here pre and post deployment as a mechanism to evaluate the software's legacy behavior. In some context, we are also thinking about utilizing A and B testing here. So not the same node that has been deployed needs to have a freeze period beforehand. But this is not something that we have come up or we have done yet, but so to say on the thinking phase. So for now, it's a pre and post, taking almost a week before the deployment, a week after the deployment, to make sure that all traffic patterns are covered for different weekdays and weekends. So from integration to delivery to deployment, all connected and orchestrated around the same time, so to say. And of course, the aspects that are done in deployment needs to be done by the customer with strong cooperation with Ericsson, but also needs to be done in systematic and continuous way. Now, in previous research, we looked at the success factor for transitioning from continuous integration and delivery to continuous deployment. And the number of factors have been emerged from this research. One of the most important factors is related to customers, and especially on the first step from continuous integration and delivery to deployment, where customers needs to have, or the pilot customers needs to have a leap of faith through having a very strong customer who believes in this way of working, ready to change their own internal processes, ready to test less, and also ready to make some parts of his network taking a software more continuous is an important. In addition to some other aspects like backwards compatibility of the software, so no surprises are really coming with any new software that are pushed to the customer, and support and monitoring, so having the data pipeline, collecting both performance and diagnostic data back to the software development organization and Ericsson in this case, and also being able to spot any deviations, either they are impacting KPIs or not impacting the KPIs immediately when they are observed. We also have found that documentation is a very important aspect of the success of continuous deployment. Now, this is in contradicting what agile software development practices are advocating. So less documentation, working software as priority number one. But in our case, and probably in the business to business software development cases, this is extremely important because customers would like to know what is the new software, what are the new features and contents the new software contain, in order for them to adjust and have the understanding of have the right understanding of the expectation of the software. Now, Helena, I think it's exactly 12:20 right now. I still have a few more slides. Is it okay to continue quickly, or?
You can continue quickly and then leave a couple of minutes in the end.
Right. CD zone is an area where we select from the customer network together with the customer, and it has to represent all different configurations that the customer has. So someone can say it's a small scale of the full network. And this is a picture here depicting a CD zone node that is located by Ericsson's office. So we elect the zone in order to be representative, but also to contain some sites that are more friendly than others, enabling us to identify problems in the software immediately if there are something in the new software. And in one way to do that is to deploy the software to sites that cover Ericsson's offices or the customer's offices, making the people within Ericsson or the customer the first ones to be exposed to the new software, and the ones to report any new deviation of the software if there are any. And in this case, this is from one CD customer. So the site is covering Ericsson's offices, and we deploy the software there in the first day after the release, and after, of course, the lab testing has been completed, and then one day after, when all the KPIs are fine and no major deviation, no one also from the users complain about the performance, then the software is deployed to the rest of the CD zone. Benefits of CD, this is also another research we have conducted based on a 3G continuous deployment. And we have identified, of course, speed, quality, collaboration, and competence are the core benefits, so to say. But here in numbers, 63% reduction in number of faults after the rollout of the software, which is extremely significant. And less investigations after the rollout of the software, 27% reduction in this particular case. When it comes to data and support, you just want to highlight one very interesting example with the SpaceX Starship that has exploded last year after it has been after it has lifted off. And as here Elon Musk has depicted, we got all the data we need, and congratulations. The same aspects here. There's no other chance to identify a problem if it happens in production, especially in this high-paced delivery and deployment cycle. In contrast to the old model, when a problem happens, the software lifetime in production is long. So someone can take his time, or it's possible to spend some more time troubleshooting, investigating, go to the lab and try to simulate the fault and identify the problem. If when the software is released and deployed every second week, there's little time to spend on investigations, and therefore the role of data and the role of also supporting the customers in this high pace becomes really important. Now here to do that in the radio access network, of course, we collect not only the performance indicators, so things that show us does it work or not, but also we collect the agonistic information that show us if it doesn't work, what is the problem. And here there are many different information elements and different types of data that needs to be collected. So we try to collect as many as possible to address the most common scenarios, so we don't need to go back to the node and recollect information or come into situations where we don't have enough information to troubleshoot understanding the root causes. In addition to that, of course, dedicated support team, 24/7 data collection, and also babysitting and monitoring as two different activities, where babysitting is the activity of observing the KPIs and the behavior of the software immediately after deployment for a couple of hours to make sure that there are no big surprises visible. And monitoring is the activity that is done for several days after the deployment to make sure that finer deviations in the product behavior are identified and spotted. And of course, for that, we use some statistical models and also machine learning to identify the expected behavior and when it goes outside the expected behavior, as is seen in these two pictures. What's next? Scaling continuous deployment is our next, so to say, challenge. So going from a few customers who are aiming at, who are interested in time to market and have a strong drive for excellence, so to say, being the first in their benchmarking, to a model where continuous deployment is also covering all other customers that are not as eager to take newer software and not as eager to be the first in the market with the new features and functionality. So how to do that is our next challenge within the continuous deployment journey. And by this, I think I am almost done, Helena. Sorry for rushing it out.
No. Then I will stop recording, first of all.